We'll talk about the quantitative methods summary. So we essentially will go through every single reading, and I will just highlight the most important points. I'll make you do some work also, so where there are problems to do, I will let you know. I will also do a lot of reading. The intent here is to help you remember. You can read on your own, I'm sure, and hopefully you've done this before, but sometimes when people hear things from somebody else, it just sticks. So here you need to understand the various concepts related to interest rates. Interest rates can be interpreted as the required rate of return. They can be interpreted as a discount rate and an opportunity cost. I'm not going to go through details. Those are available in the regular lectures. Plus, on your exam, it's quite likely that your MCQ simply says something like interest rates can be least likely interpreted as a discount rate, opportunity cost, and sunk cost. So 3 terms that sound quite good, of which only 2 are from this list. As investors, we can view interest rate as the sum of all these. Now, this is something that you learned early in quant, and now you can relate to this a lot better given that you studied fixed income, right? And one of the things that you will realize through this review course is that many topics are connected with each other, and if you recognize those connections, then you will appreciate this material more. Interest rate is the sum of the real risk-free rate plus an inflation premium plus the default risk premium, a liquidity premium, and maturity premium. So these are all different kinds of risks, and the interest rate on, let's say, a corporate bond would represent a summation of these various risks. This particular component, the real risk-free rate plus the inflation premium, is also referred to as the nominal interest. All right. Next point is future value, present value calculations. I'm not focusing on the formulas here. I need to make sure that you know how to use the calculator. So if you haven't done this already, this is how you set your calculator to floating decimal mode. So do that. Floating decimal means that rather than your calculator being stuck on 2 or 3 or 4 decimals, it gives you the appropriate number of decimals whenever you do a calculation. If you invest 100 today at 10% compounded annually, how much will you have in 5 years? Make sure you can do this very quickly. I'd say you should be able to do this in less than a minute easily. So do this and make sure that you get the correct answer. So I'll just give you 30 seconds to do this as I go along so that you are actively listening and actively working through this lecture. All right, so hopefully you got this answer. Then the next concept is related to multiple compounding periods. You invest 80,000 in a 3-year CD. This CD offers a stated annual interest rate of 10%. When the stated annual interest rate is 10% and there is periodic compounding, then you have to divide by a certain number to come up with the rate for every period. Compounded quarterly means you divide this by 4, and the interest rate that you will plug in will be 2.5. Why is N 12? Because we have 3 years multiplied by 4 periods per quarter. The payment is 0 because nothing is happening in between, and you do your calculation and you get this number. One of the things that I want you to be good at is to have a rough sense for what is the correct answer. So if you get this answer, then this should look right to you because you have 80,000 compounding, in terms of the approximate answer, this is increasing at about 10% per year, slightly more than 10%. So if you do 80% over 3 years, increasing 10%, 10%, 10%, about 107,000 seems right. All right. What if we have continuous compounding? Then you need to know this formula. So the future value is present value. That's present value is the amount invested into e to the power of r. R is the interest rate in decimal. So for r, you will plug in 0.036, and n is the number of years. So it would be times 3. The way you do this on the calculator is, for this part, you do 0.036 into 3, and then second, and then e to the power of x. multiply all that by 50,000, and this is what you should get. Present value of an ordinary annuity, there is a formula for this, but I want you to use the calculator. So if this is the information given, this is the payments, 5%, N is 5. With an ordinary annuity, if this is times 0, the first payment is happening at the end of period 1, and so on all the way till the end of period 5. Here is what you plug in. 10 for payment represents this payment. 0 FV means that there is nothing at the end. So actually I should not say nothing at the end. What we have here is 10, 10 and so on, and then there is a 10 at the end. There is nothing other than that 10. So that's why FV is 0. You compute the PV and you get 43.29. Now before I go to the next slide, which will be annuity due, you tell me whether, if I have an annuity due, similar information, but with an annuity due, the first payment will be at time 0. Will the present value be more than, less than, or equal to this? The present value will be more because it's same 10, 10, 10, but one period earlier. So given the time value of money, if you get your money sooner, then obviously the PV is greater. So you need to be good at this. When you know that we have an annuity due, the first thing you do is put your calculator into annuity due mode. And you do that using these keystrokes. You need to get good at that. And then you plug in the numbers the same way and notice that your PV is higher. And another important piece of advice is that when you are done with an annuity due question, put your calculator back into normal mode. If you don't do that, then you will have trouble later. And I've seen several students come to me and complain that they are not getting the right answer. The reason is that they put the calculator in begin mode and then forgot about it. So when the calculator is in begin mode, there'll be this little begin on top. Make sure that it's only in begin mode if you intend the calculator to be in begin mode. All right. Present value of a perpetuity. This is simply the cash flow divided by the discount rate. So you don't need the financial function, it's a regular calculation. So if you invest this and get 5% forever, what's the cash flow? It is $5. So another way of looking at it is that if you are getting $5 forever and your rate is 5%, then what's the present value? It would be 5 divided by 0.05. Present values indexed at times other than 0. An annuity or perpetuity beginning somewhere in the future can be expressed in present value terms one period prior to the first payment. So this is critical, another classic error. If this is time 0 and you have a perpetuity that starts, let's say, at time 8, and the perpetuity is $10 forever, and the discount rate is equal to 5%, then the present value of this is equal to 10 divided by 0.05, which is 200. This 200 is at period 7. It's one period before the period where the cash flow starts. And then how do you come up with the value at time 0? You take the 200 and discount back to 0. Okay, now you also can use the calculator for solving for interest rates, growth rates. Interest rates and growth rates are similar as far as the calculator is concerned. Here are some basic calculations that I want you to be able to do. A $100 deposit today grows to 121 in 2 years. What's the rate? So you can even do this mentally, but plug in the numbers and you should get 10%. Similarly, if you have a population that starts at 100,000 and in 2 years goes to 121,000, plug in the numbers and you will have a growth rate of 10. This will remind you of fixed income. If you invest 900 today, let's say in a bond, and receive 100 coupon at the end of every year for 5 years, this is the payment. In addition, you receive 100,000 at the end of year 5. What's the interest rate? So plug in numbers. This should look a lot like calculating the yield to maturity on a regular straight bond. So this is the answer that you should get.